children, how are you all? I hope all are doing well and studying too. Have you completed the notes and homework? Yes, I know most of you have completed it. Now I will have a test paper for you in the next class using Google Forms, where you will be getting a question paper. It's like quiz. So you will be having the question and some options. You have to click on the right option and then submit the form so that ma'am will get all of your marks and you also can view your score. Alright? So study the topics which I have covered till distributive property part 1. Now we will do the distributive property part 2 in this video, where first you will visualize what is distributive property using a geometrical figure rectangle. So before moving to the classroom, let us visualize distributive property. For that, ma'am is going to take two rectangles and find out the area of these two rectangles separately and add. Then afterwards, ma'am will combine these two rectangles to a single rectangle and find its area. So from the figures, we will understand that both the areas are same. So let us start. Consider this first rectangle. In this rectangle, you can see the length is A and the width or breadth is B. So what will be the area of this particular rectangle? You have studied how to calculate the area of a rectangle in the previous class. Do you remember that? Yes. For those who have forgotten, the area of a rectangle is length into breadth. So what is the length here? It is A and breadth is B. So area of this particular rectangle is A into B. Now consider the second rectangle. In this rectangle, the length is A and width is C. So what will be the area of this rectangle? It will be A into C. Understood? Yes. Now if we add these two areas, you will get the answer A into B plus A into C. Same. The area of the two individual rectangles are same as this blue rectangle. So what is the length and width of this blue rectangle? The length is same as A, but the width you will get by adding B and C. That is B plus C is the width of this rectangle. So the area of this blue rectangle will be A into B plus C. And we now know that area of this blue rectangle is same as the area of the combined rectangle. Thus we can see that A into B plus C is same as A into B plus A into C. Here A is distributed to B and C. Hope you understood this clearly. Now you can visualize what is distributive property. So now we will move on to the classroom for further studies. That means the different types of questions you have to solve using distributive property. Shall we go? Today we will learn the applications of distributive property. So ma'am will teach you different types of problems which you will face in this chapter, which you have to solve using distributive property. Okay? Let us start. Now in the first type, you will get a problem like 15 into 135. But your natural instinct says that you have to multiply because of this multiplication symbol. But then in the question, it is given evaluate using distributive property. So you have to use distributive property for evaluation. So how will you use distributive property? So first we have to think about the distributive law. We have studied two types of distributive law. One is distributive property of multiplication over addition, and the second one is distributive property of multiplication over subtraction. So first of all, you think about that. So I am just writing that for addition it is A into B plus C is equal to A into B plus A into C. This is distributive property of multiplication over addition. Now secondly, we have studied A into B minus C, which is equal to A into B minus A into C. This is distributive law for multiplication over subtraction. Now how will we use this law here? So for that you have to make this to this form. Make this given operation into this form. So you can see first element here, three elements are there, A, B and C. Here we have A as 15. So I am taking A as 15. Now how will I convert 135 in the form B plus C? So for that, first of all we have to see the number. The number is 135, which is almost near to 100. 135 is between 100 and 200. But 135 is more near to 100. So I can expand this 135 as 100 plus 30 plus 5. We have studied this expanded form in class 5. Yes or no? Yes. A given number is expanded like this. So when I expand this, I will get 100, 30 and 5. But here it is only B and C. Two numbers are there. Here I have three numbers. So what will I do? I will use this distributive property. I will extend that to one more number here. That is A into, instead of B plus C, I will put B plus C plus D. Now here we have three numbers. Then what will be the answer? A into B plus A into C plus A into D. This is distributed A into, then distributed to this number B, A into B plus A into C plus A into D. So I am going to do the same technique here. Here 15 into, instead of 135 I expanded it. So that I got 100 plus 30 plus 5. I am using the distributive law. I am distributing 15 into all these three elements. So 15 into 100 plus 15 into 30 plus 15 into 5. Now what is 15 into 100? Multiplication with 100 you have already studied that. You have to simply attach that number of zeros to the given number. So 15 into 1 is 15. And how many zeros in 100? 2 zeros. I attached it to 15 and I got 1500. Plus here 15 into 30. 30 has 1 zero. I am putting that zero first. Then I multiply 15 into 3. 15 into 3 is 45. If you don't know mental multiplication, simply multiply. 5 3s are 15, carry 1, 3 1s are 3, 3 plus 1, 4. You will get 45. So that is this 45 and this 0 I have added. Plus 15 into 5, it is 75. 15 into 5, 5 5s are 25, carry 2, 5 1s are 5, 5 plus 2, 7, so 75. Now what I have to do in this step? I have to add operator is addition. So I will add it. 1500 plus 450 plus 75. So 7 plus 5 is 12. 12 plus 0 is 12. So I am not adding 0 there. 12 carry is here. 4 plus 1 5. 5 plus 5 10. Again carry. 1 plus 1 2. And you got the answer 2025. So this is one way to do this multiplication using distributive property, that is 15 into 135 is equal to 15 into 100 plus 30 plus 5. We have expanded this number 135 as 100 plus 30 plus 5. If you add 100 plus 30 plus 5, you will get the same answer 135. But now this is in the form A into B plus C plus D. So 15 into 100 plus 15 into 30 plus 15 into 5. Then when you have done all those operations, you got 1500 plus 450 plus 75, which is equal to 2025. In the second case, you can see the number is 98. Instead of 135, it is 98. So when I expand, it will become 90 plus 8. Then multiplying with 90 plus 8 is little bit difficult. So if I can see a number which is more near to 98. 98 is between 0 and 100. And 98 is more close to 100. So how will I make this 98 using 100? I have to subtract from 100. How many number to get 98? I have to subtract 2. So 100 minus 2 is equal to 98. So here I will do it like this. 27 into, instead of expanding, I will do 100 minus 2 and it will be in the form A into B minus C. That is, it is distributive property of multiplication over subtraction. So what is A into B minus C? It is A into B minus A into C. So here I have to distribute 27 to 100 and 27 to 2. So 27 into, that operator is very important. 100 minus 27 into 2. 27 into 100, very easy. 27, add 2 zeros here. Minus 27 into 2, 54. 7 2s are 14, carry 1, 2 2s are 4 plus 1, 5, 54. Now I have to subtract 2700 minus 54. How will I subtract? 0 minus 4 is not possible. I cannot borrow from 0. From 7 I have to borrow to 0. So 7 will become 6. 0 will become 10. From 10 I am again borrowing. So 10 will become 9 and this 0 will become 10. 10 minus 4 is 6. 9 minus 5 is 4. 6, 2. So your answer will become 2646. And the third question, I have 197. And 197 is between 100 and 200. And 197 is more close to 200. So I can write 197 as 200 minus 3. Yes or no? Yes. So I can write 342 into 200 minus 3. Or if you expand this, it will become 100 plus 90 plus 7. So you will get 342 into 200 minus 3. So we will do this first. So 342 is to be distributed to 200. 342 to be distributed to 3. 342, what is the operator you have to distribute? It is into. 342 into 200 minus 342 into 3, which is equal to 342 into 2 is how much? 2 2s are, so first of all I will write the 2 zeros, and 2 into 2 4, 2 into 4 8, 2 into 3 6, minus here 3 into 2 6, 4 into 3 12, carry 1, 3 3s are 9 plus 1 10. And when you subtract 68,400 minus 1026. Here I cannot borrow from 0, so I have to borrow from 4, and 4 will become 3, 0 will become 10. From 10 again I will borrow, this will become 9 and this 0 becomes 10. 10 minus 6 is 4, 9 minus 2 is 7, 3 minus 0 is 3. 8 minus 1 is 7 and 6. So the final answer will be 67,374. Now what will happen if I expand it? Let us see. 342 into 197, and I am expanding 342 into, when I expand 197, it is 100 plus 90 plus 7, which is equal to, I have to distribute what? I have to distribute 342, and the operator I have to distribute is multiplication. So 342 into 100 plus 342 into 90 plus 342 into 7, which is equal to 342 into 100 is 34200. It is 34,200 plus 342 into 90. So I have 0. I wrote 0 here. 9 2s are 18. 1 carry over is there. 9 4s are 36. 36 plus 1 37. Carry 3. 9 3s are 27. 27 plus 3 is 30. So you will get 30,780 plus 7 2s are 4. 7 4s are 7 2s are 14. In 342, now we have to do 342 into 7. So 7 2s are 14, carry 1. 7 4s are 28, 28 plus 1 29, carry 2. 7 3s are 21, 21 plus 2 is 21, 22, 23. 2,394. Now I have to add. How will I understand I have to add? Because the operators are plus. So 34,200 plus 30,780 plus 2,394. So when I add 0 plus 0 plus 4 is 4, 8 plus 9 is 17, carry 1, 7, 8, 9, 10 plus 3, 13, carry 1, 4 plus 1, 5, 6, 7, 3 plus 3, 6. So you will get 67,374, which is same as this answer. But what is the problem? Instead of doing multiplication and subtraction 2 times multiplication and 1 subtraction, here I have to do 3 times multiplication then addition. That means you have to use more time for doing this problem if you go for expansion. That is the drawback. Here we can use less time, but one subtraction will come. If you are good enough with subtraction, you go for this. Okay, I prefer this. Now we will move on to the second type. So in the first type, this was the distributive law A into B plus C is equal to A into B plus A into C, or A into B minus C is equal to A into B minus A into C. So in this type, we were converting this given question to the right hand side, that is a into b plus a into c. How did I convert? By converting 15 into 135 into this form, the left side a into b plus c. But in this question, you can see that it is not like a into b plus c. Some number into second number, the same number into another number. That means it is of the form a into b plus a into c. Here you can see that a is common, a into is common. Here what is common? Here 397 into is common. See? So I have to convert this back to this form. That is second time. So I will write 397 into, then I will put the bracket because here you can see the bracket. Symbol is plus. What is left? 7 is left. I wrote 7 here. What is left here? 3 is left here. So now when bracket comes, you have to do bracket first. What is 7 plus 3? 10. 397 into 10. Don't write simply this is equal to 10 and all, because ma'am has told 7 plus 3 you have to do first. So I will do is equal to 10, then is equal to 397 into 10 and all. This is wrong. Always write the steps properly. That is very important. Always write the steps properly. 397 into, I have to do this operation first because of bracket. So 7 plus 3 is 10, which is equal to 3970. This is the answer. So this is very easy. If you do this, then you have to do multiplication, again multiplication, then addition. Instead, if you get a question like this where one number is common to both the terms, use distributive property, take out the common term outside, other terms inside, and do the operation. Now in the second question, 828 into 101 minus 828. 828 is there in both the terms, but here 101 is there and here nothing is there. So I have B, but I don't have C. But I can create one C here. How will I create? If I multiply 828 into 1, is there any change in value? No. 828 into 1 is same as 828. So A into B minus A into C. So A into B minus A into C. What is it? A into B minus C. So 828 into, it is subtraction. What is B? 101. What is C? 1. So 828 into, you have studied order of operations. So 101 minus 1 is 100, which is equal to 82800 or 82,800.
In this video, we're going to talk about a really important math concept called the distributive property. Well, at least that's what it's called sometimes. You may hear it referred to as the distributive law, or even the distributive property of multiplication over addition, by people who want to sound really technical. But no matter what it's called, the concept of the distributive property is the same. Before we actually dive into that concept, there are two quick things that will help make it easier to understand. The first is simply knowing what the word distribute means. To distribute something means to give it to each member of a group, like an old-fashioned paperboy delivering newspapers to each house in a neighborhood.
One for you. One for you. Oh, sorry. One for you. And one for you.
The second thing you need to know is the order of operations rules of arithmetic, which we cover in another video, so you might want to watch that if you're not familiar with those rules already. That's because the distributive property is actually a way of allowing us to change the order of operations we do in certain types of problems. To see what I mean, have a look at this simple arithmetic expression, 3 times the group 4 plus 6. We're going to simplify this expression in two different ways. The first way will just use the basic order of operations rules that you already know. But the second way will use the distributive property. And if we do the arithmetic right, both ways will give us the same answer. So for the first way, our order of operations rules tell us that we need to do any operations inside of groups first. And since these parentheses form a group, we first need to add the 4 and 6, which gives us 10. Next, we can multiply that by 3, which gives us a final answer of 30. Now, let's use the distributive property. The distributive property allows us to change this expression into a different form. Instead of multiplying 3 by the whole group at once, we can distribute that factor of 3 and multiply it by each member of the group individually. That means we'll make a copy of the 3 times for each member of the group, the 4 and the 6. So after applying the distributive property, our expression looks like this: 3 times 4 plus 3 times 6. Because we distributed the multiplication to each member of the group isn't needed anymore, so the parentheses can go away. Now, we can continue to simplify this new form using our order of operations rules. Those rules tell us to do multiplication before addition. So, 3 times 4 is 12, and 3 times 6 is 18. The last step is to add those two results together. 12 plus 18 equals 30. Well, look at that. We got the same answer in both cases, which means our original expressions are equivalent, even though they have different forms. In the first form, the factor 3 is being multiplied by the entire group all at once. So we needed to do the addition inside that group first. But in the second form, we use the distributive property to rearrange the expression so that the factor of 3 is multiplied by each member of the group individually instead of the whole group all at once. Distributing that factor made the group go away, so we didn't have to do the addition inside that group first. So the distributive property is basically a way of getting rid of a group that is being multiplied by a factor. If you distribute the factor to each member of the group, you'll get the same answer you would if you calculate what's in the group first and then multiply. And it works no matter how many members are in the group. Like in this problem, we have to multiply 4 by the group 1 plus 2 plus 3. Again, let's try simplifying this both ways. In the first way, we start by simplifying what's in the group. 1 plus 2 plus 3 equals 6. And then we multiply 4 times 6, which gives us 24. Now, let's use the distributive property. We distribute a factor of 4 to each member of the group, which makes the group go away and allows us to do those multiplications individually. 4 times 1 is 4, 4 times 2 is 8, and 4 times 3 is 12. Finally, we add up those three individual answers. 4 plus 8 is 12, and 12 plus 12 is 24. See, the distributive property gave us another way to arrive at the same answer. It's like the distributive property is an alternate path that you can take to arrive at the same point.
Well, what are you doing here? I'm always here.
Okay, great. We have two ways to get to the same answer. But why do we need two different ways to do the same calculation? And it seemed like the distributive property way was even more complicated than the regular way. Why would we ever want to use it? That's a good question. And it's true. There are times when the distributive property way is harder, like in our first problem. It was easier to just go ahead and simplify the group first because it's easy to multiply 3 times 10 mentally. But there are also times when the distributive property way is easier. Like in this case, 8 times the group 50 plus 3. If we decide to simplify the group first in this problem, we end up needing to multiply 8 times 53, which is not so easy to do mentally. But if we apply the distributive property instead, we can change the expression into 8 times 50 plus 8 times 3, and that's easier to do mentally. 8 times 50 is 400, and 8 times 3 is 24. So the answer is 424. Realizing that the distributive property can make some calculations easier to do mentally can come in really handy for certain basic multi-digit multiplication problems. That's because you can break up the multi-digit factor into a group sum, like expanded form, and then distribute the other factor to the members of that group. Sound confusing? Here's what I mean. Let's say you need to multiply 5 times 47. Well, you could just use the multi-digit multiplication procedure, or you could change this into a problem where the distributive property will make it a little easier to do. The key is to realize that you can replace the 47 with 40 plus 7. Then the problem becomes 5 times the group 40 plus 7. And the distributive property lets us change that into 5 times 40 plus 5 times 7. Those two multiplications are easy to do. 5 times 40 is 200, and 5 times 7 is 35. So our answer is 200 plus 35, or 235. Want to see another example? Let's apply that same idea to this multiplication problem. 3 times 127. But instead of 127, let's change that into the group 100 plus 20 plus 7. We need to multiply that by 3, and the distributive property lets us distribute that multiplication to each member of the group. 3 times 100 plus 3 times 20 plus 3 times 7. That helps because we can do those mentally. 3 times 100 is 300. 3 times 20 is 60. And 3 times 7 is 21. All that's left to do is add those three products up, which is not too hard to do mentally either. 300 plus 60 plus 21 gives us 381 as our final answer. Now, before we wrap up, there's one more important thing that you should know about the distributive property. You already know that the distributive property works when the members of a group are being added, but it works the same way for members of a group that are being subtracted, like in this problem, 7 times the group 10 minus 4. You could do this problem the typical way and simplify the group first. 10 minus 4 is 6, and then 7 times 6 gives us 42. Or you could use the distributive property. You distribute the 7 times to both members of the group to get 7 times 10 minus 7 times 4. 7 times 10 equals 70, and 7 times 4 is 28. And 70 minus 28 equals 42. Again, both ways are equivalent. So the distributive property works for groups of any size, and it works the same for group members that are being added or subtracted, even if there's a mixture of addition and subtraction in the group. But the distributive property doesn't work when the members of a group are being multiplied or divided. For example, if you have 5 times the group 2 times 3, you can't distribute a copy of the factor 5 to each member of the group without getting a completely different answer. And the same goes for division. If the members of a group are being divided, like 4 times the group 6 divided by 2, you will not get the right answer if you distribute the factor 4 to each member. That's why the technical name is the distributive property of multiplication over addition. You're distributing the multiplication over all of the members of a group that are being added. And the reason that it also works for subtraction is that subtraction is really just a negative form of addition, since subtraction and addition are inverse operations. All right, so the distributive property is a handy way to rearrange arithmetic expressions. It's like a tool that you can use in certain situations if you think it will make a particular calculation easier to do. And even if you don't end up using the distributive property a whole lot for arithmetic problems, it's still a really important math concept that will be even more useful when you get to algebra. Until then, be sure to practice what you've learned in this video by trying some of the exercise problems. Practice is the best way to make sure that you really understand.
Is that clear to you, children? Ma'am will be giving problems related to these types along with the video. Do it and practice it.